Okay, so this is for two-dimensional vectors. And just a quick reminder, vector is anything that has both magnitude and direction. That says magnitude. Okay, remember it's like magnitude is the body of the arrow and direction is the point. Very simple. Okay, so some that we have talked about, some vector quantities that we have talked about have been acceleration, velocity, and delta x, which change in position, that is displacement. Another way to state delta x, so it has the arrow, is just with an S. By the way, the arrow is just like an accent or any kind of like, something that modifies a letter. It always points this way. It does not mean that the object is headed to the right. It just means that it has direction. We're going to talk about this a little bit and how it's not distance. Okay, so the way that now I want to be real clear about the difference between a map and a graph. Maps do not equal graphs. I don't need to see anything plotted out on Cartesian anything. Not at this stage anyway. Really not at all this year. So graphs and maps, two different things. Please keep that in mind. Let's just go ahead and jump into a pirate map. Actually, do this. Okay, so we'll do a pirate map. Let's say that you're gonna start off here. Let's say that, because pirates put X where the treasure is, let's say that's like your initial starting spot. And then this is your final. That's where your, whatever, that's supposed to be the treasure. Whatever, that's your treasure. And let's say you go dot, 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 just all the way around like this. Okay, so we need to talk about what distance is. Oh, also, let me put a compass on here. North, south, and Miss Coley taught me something really cool because I could never remember this other thing. West and east spells we. You might have already known that, but I just thought it was cool. So most people will tell you north is positive and east is positive. That just kind of makes sense, but we're going to actually state it. And I'm going to go one step further in this. I am going to say that north and south, let's call that your y-axis. I'm going to say that's y positive. So y is up and down, not for a graph. Do not put x and y on a graph. Do not do it. Okay, and then let's say, hopefully this turns out yellow on here. Sometimes it looks funny when it's a video. We're going to say yellow is x, and I'm going to say that this is positive. So east, west, x, north, south, y, north being positive, east being positive, or top and right. So let's see. So now what I had everyone do is distance and how far. Distance is like this path that you traveled. How far apart they are is like from here to here. So I'm going to do distance in yellow, like you did in class. So that's your distance. Distance is not a vector. See, it's just all curly. It's no particular direction, something like that. Now what I'm going to do is, I think there's a shape here. Let's see. Don't use the pen for this. I'm going to go from where we start to where we finish. And let me do that. I'll do that in green. And the weight. Sorry, I want to do it in green. Okay, so where we started to where we finished is this big green kind of arrow that is different from distance. And that's actually going to be your displacement from where you start to where you finish. You can see that they're different. This one has a clear direction. So I'm going to say that that is displacement. Remember, the S is displacement, and it is a vector. See, right there, it's a vector. Okay, so the question is this going in the X direction? Probably should have done a different color from yellow. Or is it going in the Y? Whoops, I guess I should say X direction. Or is it going in the Y direction? Let's see. Okay, so hopefully you caught that I just kind of messed that up. All right, basically, is the green arrow going up and down or side to side? Y I did in blue, I messed up my color coding. Y I did in blue, X I did in yellow. So, if you said both, you are right. This is actually a two-dimensional vector. It's going north and south and east to west. So, this is how we look at it. First, I'm going to draw a little tiny ant. Well, not that tiny. And I want you to think about the ant going from where you start to where you end up. This ant has really been looking for this treasure forever. It's a very results. It's an ant that's focused on the result, or result ant. Get it? It's the resultant vector. Now we're going to look at the pieces of the resultant vector because the ant's not magical. It can't fly. It would have to go along. Think of an Etch-a-Sketch. If you know what an Etch-a-Sketch is, how it can only go up and down and side to side, that's kind of how this goes. So let's go Y, which is, I'm checking, it's in blue. Okay, let's look and see how far this thing had to go in the Y direction. So that would be up and down, so we're going to go down. And a lot of times you'll see this dashed, but that's almost impossible to do with this kind of pen. So let's see, kind of eyeball it right here. That is like this. So this is going to be your Y component. Component, like pieces, parts, Y component vector. Okay, and then I'll do a different yellow. Okay, now this is X. I'm going to go over, so we're going down and over. I could have also gone over this way and down, but I just picked this way, just as long as you get it to the triangle. Okay. Because I wanted to do yellow and blue made green. This should be a straight line. Seriously, almost impossible to write on this thing I have. Alright, so I'm going to put my arrow this way, and this is going to be my X component vector. Okay, so notice these component vectors, they're different from the little ant that started where it started and finished where it finished. The component vectors go tip to tail, just like you would on an Etch-a-Sketch. Like the Etch-a-Sketch, you would have drawn down and then over. So think of the Etch-a-Sketch for components. Okay, now, how would you find out how far the ant actually traveled if you could, say, measure your blue and your Y and your X component? A lot of you probably say the Pythagorean theorem. Please don't do that. Let me show you the easy way. It's called unit vector notation. I think I can get this on here. And if you have questions on this, please ask. So unit vector notation, and you know what? I'm going to stop this here because this is long enough for one video. And I'm going to do a video on unit vector notation in just a second.